Yeah, so let's start the discussion of this junior JEE main weekend test 2, this paper discussion. We start from the scratch, from the very first question, right? This is question number 1, okay? So what is the question here? Question is there that an oxide X2O3 is oxidized to XO4 minus by Cr2O7 minus in acidic medium. The number of moles of X2O3 oxidized per mole of Cr2O7 minus. Here one thing you understand that X2O3 is oxidized to XO4 minus. What is the oxidation state of here, the X here? Minus 6 will go that side. This one is plus 3. XO4 minus, this one is plus 7. 4 into minus 2 is equal to minus 1. So 8 will go that side. 8 minus 1, 7. That is the oxidation state of this one. Right? And Cr2O7 minus Cr2O7 minus is getting converted to Cr3 plus in the acidic medium. So here the oxidation state is plus 6. You have already calculated its oxidation state number of times. Here the 7 into minus 2, that is minus 14, will go the other side, that is the 14, charge is minus 2, 14 minus 2, 12. And they are the two chromium atoms, so they are that divided by 2, we are getting the plus 6. What is the N factor for this one? N factor for this one, change in oxidation state per mole of dichromate ion, that is the plus 6 to plus 3, 3 per atom. But how many atoms are there? 2 atoms. So 3 into 2 is equal to 6. And here plus 3 to plus 7. Change is there? 4. Right? So there the M factor in this case is equal to there. That 4 is the change per atom and the 2 atoms are there. 4 into 2 is equal to 8. An interesting thing, I hope you know there that X factors, they're the N factor, sometimes also called X factor. N factor is cross multiplied to find here the stoichiometric coefficient. So you will say here that in this equation, you will write here that 6 is the N factor for this one, 6 into X2O3, that will react with 8 into Cr2O7 minus. That is giving already, you know, this one XO4 minus, this will give here the Cr3 plus. I'm not here to balance this equation, right? So, but this one is one thing sure, that this one is not in the simplest ratio. There the 6 and 8, we take here the 3X2O3 that reacts with 4Cr2O7 minus, and that gives here XO4 minus plus Cr3 plus. Now what is the question here? Number of moles of X23 oxidized per mole of Cr2O7 minus. So you can write here per mole of Cr2O7. So you find here the 4 moles of Cr2O7 minus. There the Cr2O7, number of moles of X23 oxidizes 3 moles of X2O3. 3 moles of X2O3. Question is there? Per mole of Cr2O7, so the 1 mole will oxidize here 3/4 moles of X2O3. 3/4 moles of X2O3. I hope it is clear. So your answer is 3/4 moles. of X2O3. Done. Right? Good. Move to the next question. Next question is an element X forms X2 plus in X5 plus ions. X is here. That forms here the X2 plus. That forms here also X5 plus ions. Given if the equivalent weight of X5 plus ions is 12, equivalent weight of X5 plus is equal to 12 given, but one thing you understand, equivalent weight is equal to what? Equivalent weight is equal to atomic weight divided by, there the n factor, change in oxidation state per mole of the substance, and that is equal to what? Atomic weight. What is the atomic weight? That is not, we don't know, but we know this one. What is the n factor? That we know. So n factor is equal to, we know that from this X to X5 plus. So in this case, at X5 plus, don't think like this. Total charge is 5. That's why n factor is 5. So we get here that 12 is equal to atomic weight by 5. So atomic weight is equal to 12 into 5 is equal to 60. Atomic weight is this one. Now the question is there, if the equivalent weight of X5 plus ion is 12, the equivalent weight of X2 ion. So we can find here the equivalent weight of X2 plus ion is equal to there the atomic weight by, here the charge is 2, so upon 2. So interesting here, you can say that in this case already given here, so X2 plus is equal to atomic weight given 60, 60 by 2 is equal to 30. This is your answer. Fine, very good. I hope it is clear. Right. Move to the next question. Next question is molecular weight of NH3 and N2 are X1 and X2 given here. So let's write here one equation already given, that N2 plus 3H2 that gives 2NH3, right? Their equivalent weights are Y and Y2. And molecular weight of NH3 and N2 are X1 and X2. Here the molecular weight, two things given. Molecular weight given, the molecular weight given for NH3 and N2. NH3 given X1, that is the X1. And for N2 given there that X2. Okay, fine. Their equivalent weights are Y1 and Y2. For this one given Y1 and this one given the Y2. Fine. We can find here. What is the Y1 equivalent weight of this one? Y1 is equal to there that molecular weight by its n factor. Molecular weight by its n factor of this NH3 is what? 3. So we find here the molecular weight given there that X1 by there the 3. What is the molecular weight for equivalent weight for this one? Equivalent weight N2 is getting converted to NH3, so it is basically -3. Its oxidation state is 0. This one is present in its elementary state, so its oxidation state is 0. 0 to -3 change is per atom 3. N2 means 2 atoms are present in the molecule. So there that N factor is 3 change into 2 number of atoms is equal to there the 6. So this one is equal to the X2 by there the 6. What is the 6? 6 is the N factor. How did you find this 6? Change is there the 3. How many atoms are there? 2. That's 3. 3 into 2 is equal to 6. Okay. So X2 by 6. Now the question is there Y1 y1 minus y2. So the y1 minus y2 is equal to the x1 by 3 minus x2 by 6. So you find here, there the 6 in 3 to the 6, 2x1 minus 6, 1. There this one is x2. So what do you find here? 2x1 minus x2 by 6. This is the answer, right? Move to the next question. Next question is this one. An element X having equivalent mass E forms general oxide XMON, right? XMON, its atomic mass should be, okay. Element having equivalent mass E forms general oxide XM. So you can understand that here compound is XMON. How it forms, basically, if you just think its formation, then you will say that M moles of X reacts with N mole of there that oxygen. Then it gives here basically XMON. I write here in the simplified form, an oxygen atom I write. I could have written there the O2 also. Then that time it will be changed right now and by 2O2. But it's okay. So here one thing you understand that we have to find that what weight of question is atomic mass should be. The atomic mass should be, so for that you understand consider this one, that equivalent weight is the weight of the substance which combines with or displaced by 8 gram of oxygen. Here it is oxide formation. There the X combines with O, so it is oxide formation. So here you can say that N into 16 gram, right, combines with if its atomic mass is A, if its atomic mass, here you write, let's assume atomic mass of X is equal to A, right? So is there with the MA gram. A is the atomic mass, M is the number of moles, so number of moles into atomic mass, this much gram. Then there that 8 gram combines with the N into 16 gram combines with this one, so the 8 gram combines with MA divided by there the N16 into 8 gram. This much gram. So you can say whatever is the weight of X which combines with 8 gram of oxygen, that is its equivalent weight. An equivalent weight given there the E. So you can say that equivalent weight is equal to there the MA by there that N16 into there the 8 to just 16. So you are getting here equivalent weight is equal to right, MA upon there the 2N. Question is there, atomic mass should be. So the atomic mass is equal to E into 2n divided by m. Yes, that's it. Conceptual. Based on definition, right now, no big mathematics and all these things are concerned here. Answer is 2en by m, right? Move to the next question. What is the question here? The concentration of same aqueous solution of glucose is determined by two students, Nitin and Abhinay. Nitin reported the concentration 20% to the volume. Abhinay reported the concentration 25% to the volume. Right? If both the concentrations are correct, then the density of solution is, question is there. Here you have to find the density of solution. Okay, fine. How to find it? You have been given the percent strength that you see this one. Nitin reported 20% weight by weight. And Mr. Abhinay, right, reported 25% weight by volume. For the same solution, when we say the same solution, it means the molarity will be same or the weight of the solid will be same. So you can express here, suppose we think here the molarity. What do you know about the molarity? Molarity is equal to, there the x percent into there the 10 upon there the molecular weight. This one is molecular weight. That is the molarity. When there the percent strength given weight by volume. And for this one, what is this? Molarity is equal to x percent into there the d into 10 divided by there the molecular weight. We have done this formula in detail that how it forms, right? So now molarity will be certainly same because this is the percent strength expression for the same solution. So let's write here. We can write here that 20 into d into 10 divided by molecular weight. Same solution of glucose is determined. It is the glucose solution. Molecular weight is 180. What is the molecular weight? Already you know. There the glucose. Glucose is what? C6H12O6. So molecular weight is 180. Is equal to, as molarity is same, so I write here 25 into there the 10 divided by molecular weight 180. So 180, 10, 10 cancelled. So what we find here? 20 d is equal to 25. So d is equal to 25 by 20. Right? 5, 5 ja, 5, 4 ja. So d is equal to 5 by 4 is equal to 1.25 gram per ml. Yes, this is the answer. So simple, right? Move to the next question. You see this one, that what was the question? An answer is 1.25 gram per ml. Right. I hope there should not be any doubt regarding this question again. Right. Move to the next question. Here, D5W refers to one of the solution which is used as an intravenous fluid. It is 5% by mass solution. 5% by mass, by weight. Solution of dextrose C6H12O6 in water. The density 5dW is 1.08 gram per molarity of the solution. Just now we have done, right now. So what we know, the molarity is equal to there the percent strength weight by weight into there the 10 into D upon molecular weight. So molarity is equal to, that is given the 5% by weight into there the 10 into density is 1.08, that should be divided by 180, right? So now you see this one, that to simplify this calculation, what we will do, 0 0 cancel out right now. So we get here the 5 into 1.08 divided by 18. 5 into, let's do calculation, right? 5 into 1.08, that is 5.4. 5.4 divided by 18, and so you know this one, 5.4 divided by 18, 18 3 0.3. This one is the molarity, 0.3 is the molarity. Done. Move to the next question. When 70 ml of 3 molar Na2CO3 solution is added to 30 ml of 1 molar NaHCO3 solution, the molarity of Na plus. We have two solutions. We have solution 1, and that is 70 ml 3 molar, and that is Na2CO3. You know one thing, that Na2CO3 in the solution will give here the 2Na plus CO3 2 minus. At the same time, we have another solution, solution 2. That is 30 ml, 1 molar, 1.0 molar. This one is NaHCO3 solution. NaHCO3 dissociates, gets ionized as Na plus, plus there the HCO3 minus. Okay, how to find here? What we have to find? Molarity of Na plus. Very simple one. Molarity of Na plus we can find here. Molarity of Na plus is equal to number of moles of Na plus from solution 1, total number of moles of Na plus, a plus number of mole of Na plus from solution 2. Okay, this is the total number of moles of Na plus, and that should be divided by total volume, right? Total volume should be there in liter. If here, in order to find this number of mole, you are using here the ml, then here also you can use ml, right? So fine, we'll write here that molarity of Na plus is equal to number of mole of Na plus. How to find the number of mole of Na plus? M into V is the number of moles of Na2CO3. So number of moles of Na plus will be 2. So we write here 2 into, this one is 3 molar into 70 ml. We write here in ml. We can write, if we write here the ml, then there that for other also ml, and total volume also in ml, plus. Why 2? Because 1 mole of Na2CO3 gives 2 mole of Na plus. Again there, here NaHH3, in this case 1 mole of Na plus, so there the 1 into number of moles of NH, number of mole of NH3 is 30 into there that 1.0. This one thing you understand that here we say number of moles, but this is the millimoles in this case, right now. When we express this, when the volume is there in ml, then what we say? M into V in ml, that is the millimoles. To convert that into moles, that must be divided by 1000. So this is divided by total volume in ml. Total volume in ml is 30 ml plus 70 ml and 30 ml in ml. Yes, let's do this calculation right now. This one is equal to 6 420. 3 to just 6. A 7 6 is 42. 420 plus 30 divided by 100 means there the 450 divided by 100 is equal to 4.5. 4.5 molar. This is your answer. This one is 4.5 molar Na plus. I hope it is very clear because this one is very simple one. Systematically we found right now. Good. Move to the next question. Number of molecules in 100 ml of 0.02 normal H2SO4. Number of molecules. Question is number of molecules. The number of molecules is equal to there the number of moles into there the Na Avogadro number. That's it. One thing is there. Here M into V is the number of moles. N is equal to there that M into V. And one more thing, here you have been given 100 into 0.2 normal H2SO4, right? So what do you know? Normality is equal to molarity into there the N factor that you have learned. So you can say that molarity is equal to there the N normality upon there the N factor. I say all these things because in that way, with this understanding, this one is very simple one. Here the number of molecules in 100 ml. We have been given there the 100 ml of sample. That is 0.02 normal H2SO4. Or you can say there that 0.1 liter. Is it okay? 100 ml, 0.1 liter and 0.02 divided by there the 2 molar H2SO4. Why like this? Because there the N factor 4 H2SO4 is equal to 2. Right? So number of moles N is equal to there that M into V, and that we are getting M is equal to 0.01 into there the V is equal to 0.1 liter. So N is equal to 0.001. You can write here 1 into 10 to the power minus 3. Right? Number of molecules is equal to number of molecules is equal to, there I said number of moles 1 into 10 to the power minus 3 into the Avogadro number 6.023 into 10 to the power 23. It means 6.023 into 10 to the power 20. These many molecules. Done. Simple. Is it okay? Yes. Move to the next question. Next question, question number 9, the normality of KMnO4 solution. reacting in acidic medium is 1.5 N, KMnO4. This is very important information right now. KMnO4 in the acidic medium, getting converted to Mn2 plus. You know it very well, right? And what's with the normality of the same solution reacting in neutral medium? So when the reaction takes place in the neutral medium, this one is converted to MnO2. Okay. What is the oxidation state here? This one is +7. What is the oxidation state? +2. What is the N factor in this case? N factor in this case is 5. What is the N factor in this case? There the +7, this one is +4, so 3. What you can write here? Chemical reacting in acidic medium is 1.5 and there the normality is equal to the number of equivalent given. In acidic medium is 1.5 N. Normality is equal to what? Normality is equal to there that weight by their equivalent weight into there that volume in liter. Right? And that has been given here the 1.5. Okay. Here, the difference, now you understand that in this case it has been given. There the difference is, in this case, of the N factor. In this case, N factor is 5. In this case, N factor is 3. So now you write in more convincing way that normality is equal to there that weight by molecular weight, M, that is the molecular weight, okay? This is not molarity. Upon there the 5 into 5 into there the 3. Same solution, that's why I'm writing here everything same, is equal to 1.5. Okay, we can find here what is the weight of this one exactly as it is the same solution. So we write here the weight is equal to what? Weight is equal to 1.5 into molecular weight into volume upon there the 5. Right. Here in this case what you'll find here the weight. If you see this one, that if you'll find here the same thing you will do. Normality is equal to what? Weight upon there that molecular weight. That should be divided by this time by 3. So into 3. Into there that volume in liter. Yes. There the weight by molecular weight into this one normality. Here weight is equal to what you are getting? Weight is equal to there that normality into there that molecular weight into there that volume upon there that 3. This weight, that weight must be same. So we can say here now there that for the same solution, I write this much in detail, otherwise this much is not required. You understand this one, okay? 1.5 into M dash into there that V divided by there the 5 is equal to there that N into there that molecular weight into V upon there that 3. What things are common? Volume common, molecular weight common, right? So what you get finally here? 1.5 into 3 divided by 5 is equal to the normality, new normality. So what we are getting here, normality is equal to 4.5 divided by 5 is equal to 0.9. Right now, 0.9. Answer given is 0.9 and right now this is the normality. Here I have written that really technically there that how you can find it. I could have done in single step also. Once you know all these things, it can be done, but it's better to know it properly and should be done systematically. This question is easy, so you can find verbally. But when the little bit data will be complicated, that time only this process will be helping you to find this answer. Okay, now? Fine. Move to the next question. Next question is 500 ml of 0.1 normal AgNO3 is added to 500 ml of 0.1 normal KCl. Means there that AgNO3 is added to KCl. What we are getting? We are getting here the KNO3 and there that AgCl. Question is the concentration of the nitrate ion. We have to find the concentration of nitrate ion. So very first we have to find here that what weight of KNO3 forms. KNO3 will give K plus NNO3 minus. 1 mole of KNO3 will give 1 mole of K plus and 1 mole of NO3 minus. Here AgNO3, how many milli equivalents? 500 into 0.1 normal. Okay. Here one thing, when there the n factor is 1, that time normality is equal to the molarity. Number of equivalent is equal to number of moles. So in this case, you can write here the 500 ml. Okay. You write here the 500 ml 0.5 liter into there that 0.1 normal this much equivalent. It reacts with 500 means 0.5 liter into there that 0.1 normal. That time it initially it is 0, but later these two will be 0 and this will be certainly 0.5 into 0.1, 0.5 into 0.1. Means initially these two are like this. When these two will combine, these two will be 0 and this will form here 1 mole of AgNO3 combines with 1 mole of KCl giving 1 mole of KNO3 giving 1 mole of AgCl. 0.05 equivalent of AgNO3 reacts with 0.05 equivalent of KCl giving 0.05 equivalent of KNO3, 0.05 equivalent of AgCl. So this one is 0.05 equivalent, or you can say 0.05 mole. The concentration of nitrate ion in this one, concentration of nitrate ion NO3 minus normal concentration is equal to there that normal equivalent number of equivalent upon there the total volume. Number of equivalent is very clear. This is 0.05 divided by what is the total volume? Total volume is now there not 500, 500, not only 500. There these two together used now. So the 500 here, 500 here, 0.5 plus 0.5. It means 1 liter, 1 liter, 0.05 upon there that 1. So the normality is equal to 0.05 for the KNO3. Normality is number of equivalents upon the total volume in liter. Total volume in liter is 1. Okay, fine. Good. Move to the next question. Okay. So what's the question here now? Molality. Remember, question is molality of 1 liter solution with X% NH by weight. We say X% NH weight is 2. This is the molality. So in this question given here, the molality is equal to 2. Percent strength by weight given there the X%. But what is the meaning of molality? What you write here, molality? Molality is equal to number of moles of solute divided by weight of solvent in kilogram. Weight of solvent in kg kilogram. So in this case, let's find here. Molality is equal to N number of moles of solute, and solute is NaOH divided by weight of solvent given. The weight of solvent present in the solution is 900 gram, 0.9 kg. So from this one thing you can find here, and that is equal to 2, molality given 2. So number of moles of NaOH we can find here. So number of moles of NaOH is equal to 0.9 into 2 is equal to 1.8. That is the number of moles of NaOH. If the number of moles of NaOH is equal to 1.8, then few things we can find here, right? Now, what we can find here? Weight of NaOH. Weight of NaOH is equal to number of moles into molecular weight. So there that 1.8 into molecular weight is 40, right? This much gram is the weight of NaOH. Good. What is their question here? X% by weight. Percent strength. Percent strength by weight. Percent by weight. How do you find here? Percent by weight is equal to there that weight of solute upon there, or in 100, there it is there by weight, 100 gram of solution. Weight of solute there, that no need to write this one. We will find here in the unitary method. Okay, weight of solute in 100 gram of solution. So what is the weight of solution? Weight of solute is clear. What is the weight of solution? Weight of solution. Weight of solvent is equal to 900 gram. 900 gram. Plus weight of solid is 1.8 into 1.8 into there the 40, 72 gram. This one is 972 gram. Now it is very simple one. 972 gram of solution contains 72 gram of solute NaOH. So 100 gram, that is its percent by weight. 100 gram of solution. Very simple. 72 divided by 972 into 100. So what it comes? 72 into 100, that is divided by 972. This will come 7.4. What is this? This is percent strength by weight is equal to 7.4. So X percent means 7%. That sounds right. You see this one? There the 7 point, the value of X. X we found here. X is percent of NH by weight. Percent of NH by weight we found 7.4. It is 7.4% NH by weight. This one is 7.4% NaOH by weight. This is the X. Move to the next question. Okay, fine. 500 gram of an urea solution of mole fraction 0.2 is diluted to 1500 gram. The mole fraction of solute in the diluted solution is. One thing understand. Here the common mistake. 500 gram of an urea solution given, not the urea. 500 gram of an urea solution, not there the urea. So we find here the initial one is 500 gram of urea solution. Dilution is done. So there the final what we are getting here, 1500 gram of urea solution. How it happened here? Dilution is happening. What is the meaning of dilution? Dilution means addition of solvent. What is constant here? Weight of solute. Amount of solute is not changing at all in this dilution. Then what we have to find? We have to find here the amount of solute present in 500 gram of solution, and then the same weight of solute will be there in 1500 gram of solution, and that will be we will deduct this one, we will get here the weight of solvent, and then we can find here the mole fraction. Okay, fine. So here 500 gram of urea solution of mole fraction 0.2. So mole fraction, it means that the X urea is equal to 0.2. Actually, you know there that what is the mole fraction? Mole fraction is the number of moles of solute or given component in 1 mole of the mixture. So if there the X mole fraction of urea is 0.2, then there the X of there the H2O, which is the solvent, for that one it is 0.8, because the sum of mole fraction of all the constituents components is equal to 1, right? So here weight of urea is equal to how much? Weight of urea is equal to 0.2 into, you know urea, what is the formula of urea? Urea is NH2CONH2, right? What is the urea? Urea is NH2C double bond ONH2. So what is the molecular weight for this one? You'll get here 28 plus hydrogen 4, 4 plus carbon 1, 12, oxygen 60. So 28 for 32, 32 in 12, 44 in 60, 60. So weight of urea is equal to 0.2 into 60. Correct? Weight of urea. How much gram? This one is 0.12. 0.2, this will be 0.2 into 66, and there the 12 gram. All right. Weight of H2O is equal to 0.8 into urea, water, 18. 0.8 into 18. This one is 14.4 gram. Total weight is equal to 14.4 plus 12 gram. That one is 26.4. All right. Here I told you that this is the mole fraction. In 26.4 gram only we have 0.2 moles of urea. It means only 12 gram of urea. So this mole fraction represents this only. It is not representing that 0.2 mole is present in 500 gram. No. Then in 500 gram, how much urea is there? So we can find it in 26.4 gram of this mixture, this solution. The urea is only 12 gram. Then in 500 gram, how much? Let's write here. 26.4 gram of solution contains how much? 12 gram. Then there the 500 gram unitary method that contains 12 by 26.4 into 500. How much it comes? 12 into 500, that is divided by 26.4. We get around 227.2 gram. This much. This is the weight of solute, weight of urea, in 500 gram of solution is equal to 227.2 gram. Okay. So as we got here, so what will the weight of urea? Weight of urea in 1500 gram of solution, that is also 227.2 only. Why? That is 227.2 gram only because this is dilution, and in that one amount of solute is not changing. So we'll find here now weight of water H2O is equal to there the 1500 gram minus 227.2. So 1500 minus 227.2, distance is almost to 1272.8. Right. This is the weight of H2. Now we can find here there that we have to find here the mole fraction here. So there the number of moles N of urea is equal to 227.2 divided by 60. So there the 227.2 divided by 60. How much? That is 3.78 moles. Okay, fine. Now their number of moles of H2O is equal to 1272.8 divided by 18. So what you will do here? 1272.8 will be divided by 18, and that comes here around 70.71, right? So here what you will do? Mole fraction of there that urea in this case is equal to there that moles of urea 3.78 divided by total moles of component. So 3.78 plus 70.71. What you write here? 3.78 divided by 70.71 plus 3.78. This will come around 74.49. So now you divide 3.78 if divided by 74.49, this will come around 0.05. This one is the mole fraction of urea. Okay, I hope you got it. This one you see, this one question is there. The mole fraction of the solute in diluted solution is 15 gram of urea solution. So here from the first process we find here the weight of solute urea in 500 gram of solution. We maintain the same one in this one, and then we find here the weight of H2O in that one. We find here number of moles for urea, number of moles of water. We find here the mole fraction. Mole fraction is equal to number of moles of urea divided by number of moles, sum total number of moles of these two, and that we are getting finally 0.05. I hope you got it right. Okay. Move to the next question. Next question is question number 13. A person needs on average 2 milligram of riboflavin per day. How many gram of butter should be taken by the person per day if it is the only source of riboflavin? Butter contains 5.5 microgram riboflavin per gram. So here 1 gram butter contains 5.5 microgram. 5.5 microgram means 5.5 into 10 to the power minus 6 gram. Right now, micro 10 to the power 1 into 10 to the power minus 6. So here Very simple one. 1 gram 5.5 into 10 to the power minus 6 gram of riboflavin is present in 1 gram, then 2 milligram of riboflavin, which is required per day, right? Now, the per day that is required. So what you will do? You will find here that 5.5 into 10 to the power minus 6 gram riboflavin is there in 1 gram. You write here gram riboflavin present in 1 gram. So 2 milligram. 2 milligram means 2.0 into 10 to the power minus 3 gram riboflavin. That is the requirement. Is present in very simple unitary method 1 into 5.5 into 10 to the power minus 6 into 2.0 into 10 to the power minus 3. This much gram. So do calculation here. How you will do? Here it will be 2.0 divided by 5.5 into 10 to the power 6 into 10 to the power minus 3. So 2 point, here you will write here 2 divided by 5.5, that will be, yes, this one is 0.363 into 10 power 6 10 power minus 3. So this one is 10 to the power 3. This much go. So as you say 0.3633 gram, or you say 363 gram, right? This one is 363.6 gram. Okay, no? Right. Move to the next question. Yes. A sample of clay contains 40% silica and 15% water. The sample is partially dried, okay, by which it loses 5 gram of water. If the percentage of water in the partially dried clay is 8, what is the 8% of water in the partially dried resultant one? Calculate the percentage of silica in the partially dried clay. Okay. Very simple one. Everything is there based on there the percentage, and here the main thing is percentage is changed because there the 5 gram of water is lost. 5 gram water is lost from the weight of the clay. So let's assume here, let's assume weight of clay is equal to x gram. That is x gram. Then there the silica. What is the weight of silica? 40% of x. 0.4 x. Okay. 15% water. H2. How much? 15%. 0.15 x. Clay is heated. Clay is heated. There is minus 5 gram. That is the water. So this one is called partially dried. Partially dried clay. That is no, that is called. Here in partially dried clay, percentage of water, percentage of H2O is equal to 8. Okay. So what is the weight of partially? Weight of partially dried clay. If the clay, the weight of the clay is X, in 5 gram of water is lost. So there, what is the weight of the partially dried clay? X minus 5 gram. Correct. Now just you see this one. What is the weight of silica? Which is not changing. Weight of silica is not changing. Weight of water is also not changing. So, but with the percentage of water given here, now, so we write here the percent of H2O is equal to there that weight of H2O divided by total weight into 100. Percent of H2O is given there the 8. So 8 is equal to weight of H2. Initial weight of H2 is 0.15x. 5 gram is lost. So 0.15x minus 5. This is the initial weight. This is the weight of H2O now in this partially dried. And what is the weight of total weight of the partially dried? X minus 5 into 100. Let's find here. We can find here the value of X. So we are getting here, if we calculate this one, we are getting here the 8x minus 40 is equal to 0.15 into 100. This one is 15x minus, this one is 500. Okay. Okay, fine. We just take here that 500 minus 40 is equal to 15x minus 8x. We are getting here 500 minus 40, 460 is equal to 7x. So the x is equal to 460 divided by 7 is equal to 65.7. This is the value of x. We got the value of x. What is the question here? Question is there. Calculate the percentage of silica. Okay, fine. What is the weight of silica? Percentage of silica? No. Percent of silica is equal to weight of silica upon their total weight of clay partially dried into 100. So here, what is the weight of silica? 0.4 into x. This one is 0.4 into 65.7. Divided by. What is total weight of clay? Total weight of clay is 65.7 minus 5. Correct? This is the value of x. A partially dried is 5 gram is lost. So this one is 65.7 minus 5. So here 65.7 into 0.4. You are getting here the 26.28 divided by. This one is 60.7, right? So this you can write here, percentage of silica is equal to, what is this value? 26.28 divided by 60.7. This will come around 43 into 100 also, no? Into 100. So 43.29. Yes, this is the correct answer. 43.29. So I hope you learned it, that as we have been given here, they are the percentage of water in the partially dried, that is the 8. So we can find here the value of x, the initial weight, and once we get that one, certainly we can find here the percentage of silica. Okay, fine. Move to the next question. Calculate the weight of CO obtained on heating 200 kilogram 95% pure. Very simple, right? Weight of lime CaO. From where you get this? CaCO3 gives here on heating CO plus CO2. Right? Weight of CO obtained 200 kilogram of 95% pure limestone. So here 100 gram is giving 56 gram. So 95% pure, it means 200 kilogram we have. So actual CaCO3 is present only there the 95% of 200. So they are the 95% of 200. It means 0.95 into 200. This will come 190 gram. So 100 gram is giving 56. So the 190 gram. 190 gram will be giving here that 56 divided by 100. 1 gram is giving 56 by 100. Then 190 gram into 190. So what it comes here? Weight of CO formed. There that 56 into 190. This one is 10,640 divided by 100 is equal to 106.40. This much kg, because we are doing everything in kg. We are doing everything in kg. This is not gram, huh? This one is kilogram. Right? Yes. Move to the next question. So move to the next question. Next question is 0.2 mole of HCl and 0.1 mole of barium chloride were dissolved in water to produce 500 ml solution. To produce 500 ml solution. Here, one thing you see this one. HCl and barium chloride. HCl is giving H plus and Cl minus. You have to find the molarity of the Cl minus ion. What is the source of Cl minus? Cl minus source is the HCl, Cl minus source is the barium chloride. HCl is there, HCl is giving here the H plus in there, the Cl minus. 1 mole of HCl, giving here the 1 mole. There the barium chloride BaCl2 that gets dissociated as the Ba2 plus 2 Cl minus. So here the 1 mole is giving here the 2 mole. Very simple one. We find here the total number of moles. The molarity of Cl minus is equal to total number of moles N of Cl minus upon there the total volume in liter. Total volume in liter. That's it. In there that total number of moles of Cl minus is what? M into V. is the number of moles, right? So 0.1, 0.2 mole of HCl in 0.0, okay. 0.2 mole of HCl, so there the 0.2. As many mole of HCl, those many mole of Cl means 0.1 mole of barium chloride. So there the 0.1 mole gives 2 mole, 0.1 mole will give here the 0.1 into 2. This is the total number of moles of Cl minus. Volume is 500 ml, so this one is 0.5 liter. So what it comes here, 0.2 plus there that 0.2, it is 0.4, correct now? 0.4 are divided by 0.5. 0.4 divided by 0.5. 0.5. 0.8. Yes, this is the molarity. Cl minus is 0.8 molar. Move to the next question. For isotopic distribution C12, C14, 98.0% and 2.0% respectively. C12 is 98%. C14 is 2%. Then the number of C14 atoms in 12 gram of carbon. First we find here the atomic weight of carbon, right now. So the atomic weight is equal to percent abundance into atomic weight plus percent abundance into atomic weight 14 divided by total 100, right? So what we are getting here, 98 into 12, 98 into 12, 1176 plus 28 by their 100. So plus 28, this one is 1204 divided by 100 is equal to 12.04. Yes, this is the atomic weight. So 12.04 gram contains how much? 6.023 into 10 to the power 23 carbon atoms. 2% of this one, C14. How many C14? C14 is 2% of this one. So the 2% is how much, and that will contain 12.04 gram contains this much, so this much. 2% means 2% of 12.04 gram. It means 0.02 into 12.04 gram contains 6.023 into 10 to the power 23 divided by 12.04 into 0.02 into 12.04. So this one is cancelled out. We are getting here, as we say, 6.023 into 0.02. This will come 6.023 into 0.02. It will be 0.1204 into 6.023 into 10 to the power 23. No, This is not there now, right? This we have already multiplied into 6.023 into 23 into 0.020 12.0.023. So what you will write here in this one? You will write here 1.204 into 10 to the power 1 minus 0.12 minus 10 to the power 23. Okay. So what is the weight here now? How many? 1.204 into 10 to the power 22. Okay, done. Yeah, so move to the next question. There the mole fraction of a given sample of I2 in this one in benzene given 0.2. Molality of I2 in C6H6. There that X I2 mole fraction of I2 to 0.2 in C6H6. So the mole fraction of there the C6H6 is equal to 0.8. So from this one we can say the weight of I2 is equal to number of moles 0.2 mole, 0.2 into 254 gram. ID atomic number is atomic weight is 127, right? So this one is 254 into 0.2. This will come around the 50.8 gram, right? The weight of this C6H6 is equal to 0.8 into molecular weight of C6, 12 6 are 72 plus 6 78 into 78. This will come around 62.4. Now the point is here the molality we have to find. What is the molality? Molality is the number of moles of I2 in 1000 gram of C6H6. Although there was no need to find here this much, but we have found. So we can say here 62.4 gram of benzene C6H6 contains there the 0.2 mole of I2, right? Then there 1000 gram contains, that will be 0.2 divided by 62.4 into their 1000. So 0.2 into 1000, that is around 200. That is divided by 62.4, right? This one around 3.2. That's the molality. Molality is this one, right? Next question. In what atomic ratio O16 and O17 atoms should be taken in sample such that the average atomic mass becomes 16.72? You know this one. What is the atomic weight? Atomic weight is, let's say the O16 is X%. So what is the percent? There that percent abundance is X. Which one? 16. So the total weight of 16 is X into 16 plus. Then what about the percent dependence of 17? O17, that is the 100 minus X. 17 into 100 minus X divided by 100, right? So here we find this one. We are getting here the atomic weight is equal to 16X plus and given the average atomic mass becomes 16.72 plus there 1700 minus 17x is equal to 1672, 16.72 into 100. We take here 16x plus 1700 minus 17x. Okay, continue. We are getting here 16x minus 17x is equal to 1672 minus 1700. Okay. So this one you do. How much it comes? Minus x is equal to 1672 minus 1700. This one is minus 28. So x is equal to 28. 100 minus x. So we can say there that O16 is there 28%. O17 is 100 minus 28. Right? How much? 72. So there the O16 by there that O17 is equal to 28 by 72. How much it comes? 2 14 jam 36. Right? Somewhere is there something wrong? 16x 17 100 minus x into 16.722. 16x plus 1700 minus x. There 1700 minus 17x is equal to 1672. 16x minus 17x minus x is equal to minus 28. X is equal to 28. 28% it is coming. O16. In what atomic ratio O16 and O17? To 7 jam. It is 7:18. Answer is not there. Okay. Yeah, so just continue the leftover discussion of this junior JEE main weekend test 2. Okay. So this is the question number 20. Okay. So read the question carefully. Equal volumes of 0.50 molar of HCl, 0.25 molar of NaOH, and 0.75 molar of NaCl are mixed. The molarity of NaCl, we have to find the molarity of NaCl. First thing is there that to simplify this one, let's assume that equal volume is V. Now in this case, equal volume of 0.50 molar of HCl. So we should see here that HCl is acid, NaH is base. These two will react, will form here the NaCl, and some of the NaCl is already present here. So let's write here this kind of acid-base reaction, which is a neutralization reaction, that we have there the HCl plus there the NaOH, and that gives here the NaCl plus H2. But one thing I'm telling you, initially we have 0.50 V M into V, that is the number of moles of HCl, 0.25 V, that is the number of moles of NaH, and 0.75 V, that is the number of moles of NaCl, that is already present. Now what happens here, that 1 mole of HCl, acid-base reaction will be taking place. 1 mole of HCl reacts 1 mole of NaH, gives 1 mole of NaCl. So here 0.50 requires here 0.50, but we have 0.25. So this is less than the expected one. So this one is the limiting one. So we have to go as per NaOH only. So this one, in the next step, you can write here that this will be 0. And this will be 0.50 minus 0.25. There the V. 0.25 V combines with 0.25 V of HCl and giving here the 0.25 V of NaCl. So this one is the moles of NaCl already present. This one is the moles of HCl formed due to the reaction in between the HCl and NaH. So we have to find here the molarity of NaCl. Molarity of NaCl means what? Total number of moles of NaCl. What is that? 0.75 V plus 0.25 V upon total volume. What is the total volume? Total volume is V. There that 3V. So how much it is now? 0.75 plus 0.25. This one is 100 right now. So you should write here 1V, 1.0 V upon there the 3V. V cancel out, so 1 by 3 is equal to answer, directly answer given 1 by 3. Right now, this is the molarity. Right. So done. Move to the next question. Yes. See the question number 21. 2 liter of 1.5 molar NaH solution is mixed with 3 liter of 2 molar NaH solution, and 1 liter water is also added. Okay. The molarity of the final solution, very simple one. This one is anyway 2 liter NaH only. This one is also there the 3 liter 2 molar NaH. So we write here the 2 liter 1.5 molar NaOH. We have again there are 3 liters of 2 molar NaH, 3 liter of 2.0 molar NaOH, plus there the 1 liter of water, 1 liter H2O added. So very simple. We have to find the molarity of the final solution. So total number of moles of NaOH divided by the total volume. So there the molarity of NaOH is equal to total number of moles from this one, how much? M into V. So there the 2 into 1.5 plus number of moles from this solution is 3 into 2 into 2. This is the number of moles of NaOH. What is the total volume? Total volume is 2 liter from here, 3 liter from here, 1 liter here. So they are the 6 liter. What we are getting here? Molarity of that resultant molarity of NaOH is equal to 2 into 1.5 is equal to 3 plus 3 into 2 is 6. Upon there the 6, this one is 9 by 6. 3 2 ja, 3 3 ja 9. So this one is 3 by 2 is equal to 1.5. This is your answer. Okay, fine. Move to the next question. Good. See, the question is question number 22. The compound genome XE and F is found to have 53.5% genome. You found here genome fluoride, which contains 53.5% genome. What is the oxidation number of genome in this compound? We have to find what kind of fluoride, what is the compound first, and then we'll find here the oxidation number of genome. So one thing you understand that Xe genome fluoride, right now. So that is you write here that XEF and maybe they're the 2, maybe they're the 4, maybe they're the 6. XEFN is our compound here, right? In this one, 53.5% is the genome. So there that percent of genome, how do you find here? Percent of genome is equal to the weight of genome upon there the total or the molecular weight into 100. So what is the weight of genome? Genome weight is 131 divided by, what is the molecular weight of this one? 131 plus N Fn 9 into, oh, this one is 19. Okay. So what is there that this one 19F, right? Not F, 19N. But that is given. That is given how much? Given there that into 100, sorry, 50% now. So into 100. Just you remove this one from here. Okay. Is equal to 53.5. We can find the value of N. So this one is 13100 divided by 131 plus 19N is equal to there that 53.5. So 13100 is equal to 53.5 into 131 plus 19N into 53.5. Okay. So what we are getting here, 13100 is equal to 53.5 into 131. This one is around 7008.5 plus 19 into 53.5. 19 into 53.5. This one is 1016.5 n. So let's take here 1016.5 n is equal to 13100, right? Minus 70087,008.5. 7.5. This comes here the 6091.5. Okay. So 1016.5 n is equal to this much. So n is equal to 6091.5 divided by there the 1016.5 divided by 1016.5. It will come around 6. Okay. So what we'll say here, the formula is xenon fluoride is XeF6. So what is the oxidation state here? So oxidation state of xenon is equal to plus 6 F minus 1. So minus 1 to 6 is equal to total Xc, that is oxidation of X plus there that 1 into minus 6 is equal to 0. So X is equal to plus 6. This one is the oxidation state. Fine. Move to the next question. Right. Very simple one. Equivalent weight of a trivalent metal is 9. What is the molecular weight of oxide of this metal? What is the molecular weight of the oxide of this metal? Trivalent is this one, right? Now, the very first is this one, that equivalent weight of trivalent metal is N. So what is the atomic weight of that metal? So you know this one, equivalent weight is equal to atomic weight by the valency. So atomic weight is equal to E into valency. So very clear that equivalent weight given there. The 9 valency is there, the trivalent. So 3 is equal to 27. So suppose there that metal, let's the metal is M. Let's metal is M. So oxide is what? Oxide is M2O3 because it is trivalent, right? So oxide, what is the molecular weight of its oxide? Molecular weight is how much? There the 27. Molecular weight is equal to 27 into 2 plus 48. 54 plus 48. This one is 90 and there that 8 for the 12. 102. This one is the molecular weight of this oxide. Right? Move to the next question. Right. Good. Question number 24. Sample of H2SO4 density given 1.8 gram per ml is 90% by weight. What is the volume in ml of the acid that has to be used to make 1 liter of 0.2 molar H2SO? Yes. So 90% by weight we have been given. density is equal to 1.8 gram per ml, right? So this one is H2SO4. As everything given, so you can find here the molarity of this solution. And what's the formula for the molarity? Already you learned this one. Molarity is equal to percent weight into density into 10 divided by molecular weight. Correct? So what is the molarity here of this one? Molarity of this solution is 90%. It means 90 into 1.8 into 10 divided by molecular weight is 98. 98. And that will come around 90 into 1.8 into 10. Okay. This will be almost 1620 divided by 98 is equal to 16.5 around that. Okay, fine. This one is the molarity of this one. What is the volume in ml of the acid that has to be used to make this kind of solution? What kind of solution? 1 liter of 0.2 molar H2SO4. Okay, we know. So we can say that M1V1 is equal to there that M2V2. Here that we have 16.5 molar into there. Just let's assume that this volume is V is equal to there that question is there in ml. So let's take here this 1 liter in ml there that 1000 into M2 given 0.2. Okay, 0.2. So here the volume is how much? 1000 into 2, this one is 0.2, it means 200 divided by there the 16.5, and that will come around 12.1 something. Okay, all right, good. Move to the next question. Yes, the number of atoms present. Question: the number of atoms present in 0.5 gram atoms of nitrogen is same as the atoms in x gram of oxygen. Find the value of x. First thing you have to understand, what is the meaning of 0.5 gram? 0.5 gram atoms, when we say of nitrogen, its meaning is very clear. 0.5 mole of nitrogen as gram atoms given, so you can take here nitrogen atoms, 0.5 mole of nitrogen atoms. So 1 mole of nitrogen atom, gram atom is for gram atomic mass, gram atomic weight. This is the short form right now. 0.5 gram of nitrogen atoms is the different one, but 0.5 gram atom of nitrogen is different one. Okay, so 0.5 mole of nitrogen atoms will contain here, already you know, 0.5 Na nitrogen atoms. Okay, 0.5 mole, it means there the 0.5 mole, it means of the other one also 0.5 mole. Number of atoms present in 0.5 gram atoms of nitrogen is same as the atoms in x gram of oxygen. X gram of oxygen, so 0.5 mole only. It means it indicates 0.5 mole of oxygen atoms. Correct. 0.5 Na will be of oxygen atoms, means 0.5 mole of oxygen atoms, and it implies 1 mole of oxygen atoms is equal to 16. So 0.5 into 16 gram of oxygen atoms equal to 8 gram. Done. You have completed this one. Yes, very good. The main thing is, let's take their very fundamental approach, take the question at the conceptual level as per definition. Certainly, the question itself gave the way of the solution. Thank you.